We are back with AP Calculus. I should be putting the date every day, and I haven't been doing that. So today's date is August 28th, 8/28. Be putting it on your notes as well. Just get in the habit. Oh, thank you. So mean value theorem. It's one of the hardest theorems because it's not obvious. Extreme value theorem, obviously there's a minimum. Obviously there's a maximum, minimum. IVT, obviously if it's continuous, if you have to hold down your pencil, you have to go through all the heights in between these 2 points. This one is less obvious. All right, so this is a review from last night's homework. Make sure that we know what we're doing. What does it mean to be differentiable? First of all, let's draw the tangent lines. Oh, no. Tangent line, that's too easy. Let's just tell me what the instantaneous rate is. Is it positive, negative, 0, D and E? What is it for this one? Positive. How do I write that? If this is f of x.
F of x is greater than or equal. Greater than 0.
So f of f prime, that's talking about the derivative, the slope. F prime of what?
X.
What is our x coordinate, Gio?
1.
Exactly. F prime of 1 is
Greater.
then 0. Okay, that's positive. What about this one right here?
F prime of 2 is equal to 0.
There it is. Good job, Stego. Claire?
F prime of 4 is less than 0. You should write this down.
Less than 0. Arrow?
Good idea.
5.
5 is does not exist.
So how would you write it?
F prime of 5.
There it is. F prime of 5. D and E. What about 7? F prime of 7. Someone.
It's greater.
That's a whole.
It's a whole. Yeah, it does not exist. Discontinuous, it's a whole. So D and E. Is it clear on your notes, or does it look like filled in dot on your notes? Okay. And then finally, this last point is f prime of 8 is what? Endpoint. Does not exist.
Oh, right. Good job.
Good job, guys. All right, so there's our good review. I always love AP Calculus making these graphs too. I don't know if you could visualize what types of functions would make all of these, but this is a composition of 3 functions. Always super fun to make these graphs. This one was even harder to make, but I was able to make it. The mean value theorem. Okay, so first of all, average rate of change. Represented graphically is what? Shout it out. Average rate of change graphically is?
The line between A and
Exactly, it's just a line. Okay, so let's go ahead and do that. Let's make a line. I'm going to make my line orange because I'm feeling orange today.
No, I'm good. She's like, why would I want a ruler?
And let's label that. That is going to be the average rate of change.
We're here for you now.
Mine doesn't have the little metal thing. This is one of the ones that like Jaden and Aurelio stole out of.
Why would they take the metal?
They used to take the metal thing and like hit each other.
Oh, okay.
Average rate of change. So that is half of the mean value theorem. Half of it is the average rate of change. That is a slope. The average rate of change is the slope of this orange line connecting point A to point B, if we assume A is the first point, B is the second point. So far, so good. Nothing new. We're okay. That's a slope. Average rate of change is the slope of that line. All of us nod our heads, just we're following. Okay. This is the cool part. Average rate, and Claire, have you learned the mean value theorem? I'm curious.
Possibly.
I guess we'll
don't
see,
know
right?
The name of it, I probably know it.
Okay, so what I'm going to do now is I'm going to copy this slope. I'm going to copy the slope electronically. You're going to have to do your best to just pay attention and figure out how to do this on your own. So I'm going to copy this line and paste this line. And I'm going to change it to a color, and I'm going to try to keep it the same slope, so parallel. So can we all agree that this red line and the orange line have the same slope?
Yes.
Okay. What I'm going to say here is that this line will be tangent at least 1 point in between A and B. So if I follow the line, where is it going to be tangent? Where is it going to be tangent? If I hold option, it will stay. Oh, it's tangent right there. Boom. Is there another place that is tangent? Where?
Up above.
So follow right about. Boom, there.
Yep.
That's mean value theorem. You take the slope, the average rate of change, that slope, and that should be equal to the tangent slope somewhere.
Should we write the tangents too?
Go ahead, copy those tangent lines down. Copy that down. I'm going to write them down also. Those are called the tangent lines. So tangent and tangent. That's all mean value theorem states. If you take the average rate of change, that number, that slope, that should be the same slope as at least one tangent. You might have more than one. This is a case where you have two. You have to have at least one of those somewhere in between that's tangent. By the way, what is the name of this orange line? It actually has a name. It's not tangent. It's called something else that starts with an S. It is the secant line. It's not important to know. I'm just going to write it down as kind of a fun fact. This is called a secant. A secant line intersects at least twice, if not more. All right, so in order for this to happen, though, you need something. Anyone want to take a guess at the one thing that you need in order for the mean value theorem? Good guess. So if it's continuous, I could have something that looks
Discontinuity.
like this. Differentiable.
Differentiality.
There you go.
F of x needs to be differentiable. If f of x is differentiable, and I'm going to pause right here. What does it mean to be differentiable? You can't have these three things. You're not allowed to have these three things. What are they?
Discontinuity. Sharp corners.
Vertical
Vertical asymptotes.
asymptotes. Those three things. So it has to be continuous. And what are the three things, or what are the four things?
Vertical asymptotes. Vertical asymptotes.
Exactly.
So it's vertical tangents.
Yes. So vertical tangent is one of the three things. So it goes.
If we need both,
You
one of
wrote
us
vertical
covered.
So discontinuities is the first one. There's four discontinuities. What are the four discontinuities?
Vertical
You know,
asymptotes.
VAs and
Yeah. Okay. So you all said them more or less. It's holes, gaps, ends, vertical asymptotes, VAs.
So it's
Vertical
already
asymptotes
covered. So
go
you
in there,
do
and then
need
vertical
both,
tangent.
but one of them is specified outside. Yeah.
So those are the four in that first category of being discontinuous. And then the second one is sharp corners. Third one is vertical asymptote, or not vertical asymptote, a vertical tangent. All right, so as long as you're differentiable, boom, you've immediately unlocked the power of mean value theorem. It is guaranteed now, because it's differentiable, that this thing, this is how it's presented in textbooks. I love presenting it first graphically because it makes a lot of sense. This is how it's presented first in textbooks. This thing right here, how do I interpret that? What is f prime of c? If we assume that c is some point, let's call c some point. This is what?
Slope of some
Not just the slope of the
tangent.
tangent. So this is saying the slope of the tangent at some point. Whew, that was a lot to unpack just by saying f prime of c. F prime of c is interpreted as the slope of the tangent at some point, which is what these red things are saying. This is the slope of the red tangent, slope of the red tangent. This slope of the tangent is going to be equal to this thing. What is that? We just talked about it this morning.
The average.
Average rate of change. Yes.
There you go.
This thing is the average, or the slope of the average rate of change. So I'm going to say the slope of the average rate of change.
Is that just the A or is it both the B minus?
It's all of this thing. This whole thing is the slope of the average. Why does it do that? If I scroll down and back up, it usually fixes it. The slope of the average rate of change. So it's saying these two slopes are guaranteed to happen. That one slope will equal the other slope if that function is differentiable somewhere in your interval. If you're not differentiable, this is not guaranteed. It might happen, but it's not guaranteed. If you understand this concept of making the slope for the average rate of change using that line, and then copying the slope of that line and trying to match it somewhere, that's mean value theorem. Let me get a fist of 5. How well do you think you know mean value theorem up to now? So I have a 3.5, a 3, a 4, and a 4. Okay, those are good. Let's test that knowledge now with these two examples. So we're on the back. We're going to say we have a function f, and it is differentiable. We have now unlocked what? It's differentiable, so we've unlocked which of the three theorems? IVT, EVT, or MVT?
All of them.
Technically all of them. But we've definitely unlocked MVT.
We don't really have closed. Does differentiable include closed?
Oh, that's true. So we haven't unlocked EVT. We've unlocked IVT and MVT. Someone explain, why have we unlocked IVT? What did IVT need again? Intermediate value theorem?
Continuous.
Continuous. But if it's differentiable, which it says it is here, it says it's differentiable, it can't be discontinuous, so therefore it has to be continuous. You cannot have holes, gaps, ends, or VAs if it's differentiable, right?
Wait, so doesn't differential automatically mean it's going to be closed? Because if it was open, then it wouldn't be continuous.
You can have open and continuous.
If it's open, that means that you have no endpoints, right? So, and it has
We
to.
were doing that one homework where there were some where IVT worked and that EVT
Oh, yeah,
didn't work
okay.
on.
I think it really depends on what the types of intervals are, I think. So I don't think it's enough to unlock EVT just by saying it's differentiable, is my understanding. All right, so we have this. The height at 3 is 8, and the height at 6 is 17. So I have this point 3, 8, and this point 6, 17. Can you visualize what that looks like on a graph? I have this point 3, 8, and 6, 17. Okay. You guys now need to explain why there has to be some C in between 3 and 6 in the same interval that we were talking about between 3 and 6, 3 and 6. There has to be some x-coordinate such that I have a tangent slope equal to 3. If you had a 5 out of 5 for MVT, you could answer it like that. None of us have that, so let me walk through this with you. Rewrite MVT. Every single time in AP Calculus, not just in Calculus, because in Calculus it's way too hard. In AP Calculus, they narrow down the field. If you ever see F prime, and it's asking you to show something or explain something, it's always going to be MVT. MVT proves slopes. So I'm going to come back up here. This proves slopes. That's the important thing. IVT proves what? That's MVT. What is IVT? IVT proves heights. EVT proves these two things. MM,
Oh, minimum and maximum.
extremes or minimums and max. And then MVT proves slopes. So if you ever are dealing with slopes, you are guaranteed to be dealing with MVT. So because we're talking about, let me come back up here. I accidentally did this. Because we're talking about F prime of C, we're dealing with MVT. Write the definition of MVT while filling in things. Unless you can't fill in things, in which case just copy down this thing. This formula right here, copy that down. See if you can remember what it's saying. F prime of C is equal to F of B minus F of A all over B minus A. You know its tangent is equal to average rate of change. You should know each of those. Try to do it from memory. If you need to look up the board, that's fine. And now I'm going to write it down. Let me erase this thing. It's probably going to mess it up. My computer hates erasing. Didn't mess anything up. Okay, cool. So this is saying that F prime of C is equal to F of B minus F of A all over B minus A. All I've done is I've copied down MVT. That's what MVT says. I'm allowed to use it because
It's differentiable.
it's differentiable. Differentiable is the thing that unlocks MVT, and I've copied down MVT right here. Okay, now let's start filling in things. I don't know F prime of C. I'm trying to prove that it's 3. Well, I do have all this stuff, though. So let's fill that in. So F of B is what? Well, I guess we should choose B and A. Should we say that 3 is A and 6 is B? Is that okay? A is the first point, B is the second point. Then what is F of B? What is F of 6? 17. What is F of A? What is B? What is A? What is 17 minus 8? What is 6 minus 3? What is 9 divided by 3? So it's saying that this right-hand side that we did right here, this is all the right-hand side is equal to 3. Therefore, the left-hand side must be, you have now proved that F prime of C is 3 using MVT. There it is. Thank you, Jude. Thank you.
You gotta do the little therefore 3 dots.
Oh, you want to, okay, I thought we were going to, it's not really proof. Therefore, we'll come over here. Therefore, F prime of C is equal to 3. And then if I was being very technical, I'd say by mean value theorem. All right. Easy peasy lemon squeezy. As a general hint, if you're doing the homework on mean value theorem, you're probably going to be using mean value theorem. So, I mean, eventually it's going to be a lot harder than that. I'm going to be mixing it up IVT, EVT, and MVT. But I've already given you the hint. If you're dealing with slopes, you're going to be using MVT. Let's go on to the second and hardest example. This is one of the hardest problems that you will ever see on the AP test, knowing when and when not to apply MVT. And I say it's hard, but it really has an easy answer. So I have this graph, g of x. What type of graph is this? It is non-differentiable. Does anyone know the parent function? Y equals, it's the absolute value of x.
Oh, that's
Absolute value of x makes v's. So this is v, and then I have to shift it around a little bit, but that's a parent function. So it's an absolute value function. Not needed to know, but you know it now. Okay, so the average rate of change of g of x. I need to find that. Oh, I know the equation for average rate of change. It's what? All right, let's write it down. F of b minus f of a all over b minus a. It says find that thing. Okay, I know how to do that. So on g of x, I'm using the interval 0 to 6. So 0 has a height of, all right, sorry, let's do b. 0 to 6. I'm going to circle 0 and 6. So 6 is going to be my b, 0 is going to be my a. So what is f of b? What is the height at b?
How do you know which ones are B and which are A?
A is usually the beginning, B is usually the end, and it says 0 to 6. So I'm going to say the beginning is 0, A is 0, 6 is the end, B is 6.
Does it make that much of a difference if we get it backwards?
Nope, it'll still be the same. Yeah, so you can't make a mistake. Just choose one. Usually A is the beginning though. Okay, so from there, what is the height at B? What is f of B?
4.
It's right there, 4. Yep. So this is going to be 4. What is f of A?
4.
4. And B is what? Just filling in the equation. 6, and A is 0. I'm going to pause here. Everyone sees all we're doing is filling in the equation. If there are questions, this is the time. All right, and then simplify this. That's going to be 0 divided by 6, which is just 0. Okay, so we found the average rate of change on that interval. The average rate of change on this interval, 0 to 6, is 0. And that makes sense because if I drew the line that represents the average rate of change, the line looks like this. It has a slope of 0, right? It all makes sense graphically. Okay, now it's saying, does mean value theorem guarantee somewhere in between A and B, that C is in between A and B, such that the tangent line slope is equal to the average rate of change? That's the answer. So we found it. That's the first half. We found that the average slope or the average rate of change was 0. And then the second answer is no, you cannot use MVT. We have not unlocked the power of MVT because this graph is not differentiable. We have, what is this thing called? A sharp corner. No, cannot use MVT because sharp corner. Sharp corner. And that's the second part of your answer. There are questions like this. I wonder if Arrow remembers them. I think there are 2 pre-tests or tests that have almost this exact question. Can you use MVT?
Of course I don't remember.
And it's kind of cool too. So remember back to the very first example. On the very first example, you draw that first line. That first line looks like this. And then I said, okay, we'll make another line that has that same slope. I'll do it a little bit smaller and move that line around. Where does that line, where is it tangent? Where is it tangent? Well, it can't be there. That point is not differentiable. That line is not tangent anywhere. It seems to break mean value theorem. It might go there, but that doesn't work. This line can't go anywhere because it's not differentiable. Does everyone see that graphically now too? Cool. That's it. That's all I have for you guys. All right, so